Now let us uh, see some examples on this over here. So we have to find the orthogonal projection of v on u. आता इथे प्रश्नामध्ये u म्हटलंय, but it is understood that on u म्हणजे काय, actually it is a line in the direction of that unit vector. Is that clear? Okay, so you can call it as some ru only. So let us go for it. Now you can see that v is given to us, u is given to us, so simply we are supposed to use the formula and we are supposed to find that orthogonal projection. But the point over here is whatever u is given, that is not unit in this case. They have asked us to find uh, the projection of v on u. Now whenever I say projection of v on u, it means that it is a projection of v on the line passing through the vector u. Is that clear? So in short form, most of the times we say that it is projection of v on u only. So first of all we'll find the unit vector. So here what will be my norm of u? Now it will be under root of, now inner product is given as usual dot product, so no need of worrying. So 1 square plus 1 square plus 2 square, which will be equal to under root of 1 plus 1 plus 4, that will be under root of 6. And therefore what is our new u? Okay, so our new u is, okay, I will make it as bold since it is a unit vector now, will be equal to u upon norm u, which is equal to 1 1 2 upon root 6. Okay, so now let us find the orthogonal projection of v on u. So I will say we have orthogonal projection of v on, now this bold u, okay, so that you can understand, is equal to inner product of v with u outside the bracket u, which is equal to, so what is my v? My v is given to be 5 minus 3 1. What is my u? My u is 1 1 2 upon under root of 6. So it is nothing but what, actually it is same as 1 upon root 6 comma 1 upon root 6 comma 2 upon root 6. Just keep one thing in mind. Now whatever value of u we are going to use, we are going to use this new value of u. Okay, I am not going to use this view because it was not a unit vector. So yeah, so 1 upon root 6 comma 1 upon root 6 comma 2 upon root 6 over here, and outside again u, so that is 1 upon root 6 1 upon root 6, and over here 2 upon root 6. So which is equal to, now take the inner product in this case, so it will be 5 multiplied by 1 upon root 6 is 5 upon root 6, minus 3 multiplied by 1 upon root 6 is minus 3 upon root 6, and 1 multiplied by 2 upon root 6 is plus 2 upon root 6, and outside it is point u again, that is 1 upon root 6 1 upon root 6 and 2 upon root 6. So now let us calculate it. So I guess it will be 5 plus 2 is 7 and 7 minus 3 is 4, so it will be 4 upon root 6, right? So therefore this is equal to 4 upon root 6 inside the bracket 1 upon root 6 1 upon root 6 and 2 upon root 6, so which is equal to, so 1 upon root 6 1 upon root 6 will be 6, so I guess it will be 4 upon 6 comma again 4 upon 6 and comma 4 to the 8 upon 6, so which when simplified will be equal to 2 upon 3 2 upon 3, and I guess it will be 4 upon 3. Okay, so this is our orthogonal projection of v on u in this case. Now let us go for next example. So in this next example our u is given to be 1 and they are giving us v as x. Okay, now let us check whether this norm of u is 1 or not. Okay, so here norm of u is equal to norm is under root actually, so I will go for norm u square better. Okay, So here norm u square will be integration minus 1 to 1 u of x dx, which is further equal to integration minus 1 to 1. So value of u is 1 only, so 1 dx. So integration of 1 is x, so x limits varies from minus 1 to 1, which is equal to 1 minus of minus 1, which is equal to 2. And you can see that it is not a unit vector. Therefore, what is your norm? So my norm is under root of 2. So in order to convert it into a unit vector, we are supposed to divide this u by norm. So now our unit vector, I'll mention it as unit vector, is equal to u. Remember, it is new value of u, will be equal to u upon norm u, which is equal to 1 upon root 2. And we have our orthogonal projection as orthogonal projection of v on u is equal to inner product of v with u, outside it is u, so which is equal to so inner product of, what is my value of u? I guess my value of u is 1, value of v is x, so x comma 1, so inner product of x comma 1, and outside it is going to be 1 upon root 2 again, and over here also 1 upon root 2, because we are supposed to use that new value of u multiplied by 1 upon root 2, which will be equal to integration minus 1 to 1 x multiplied by 1 upon root 2 dx, and again it is multiplied by that 1 upon root 2. So that 1 upon root 2 and 1 upon root 2 will be half, so half integration minus 1 to 1 x dx, and this will be, just a minute, this will be half x square upon 2 minus 1 to 1, so which is equal to half inside the bracket 1 upon 2 minus 1 upon 2, which is equal to 0. Okay, so our orthogonal projection in this case is the 0. Okay, just note one thing before going ahead. That your orthogonal projection is a function, so I have not mentioned the domain and codomain. Okay, just note one thing, that your orthogonal projection, okay, of v on u is a function from what? V to v. Okay, just keep it in mind, you should know it, right? Yeah, so over here in first example it will be a function from R3 to R3. Okay, so that is why whatever answer we got, it is a point of R3, as you can see. Now over here your that orthogonal projection will be a function from P2 of x to P2 of x. Okay, this should be also clear. So P2 of x to P2 of x, in the sense you are finding orthogonal projection of this x now, which is the element of P2 of x, as you can see, and whatever answer you got, that is 0, and which is also element of P2 of x. It is a 0 polynomial, right? And whatever this x was given, it is a polynomial having degree 1, which you are already familiar with. And over here the point given to us was this 5 minus 3 1, which is a point of R3, as you can see, and that's a projection काय आलेला आहे, this is that projection. Okay, okay.